Operator overloading is not unique to C++. In fact, it was one of the first concepts borrowed from ALGOL for C++ when C++ was first being created. But how C++ does it is fairly unique and extremely powerful. There are two distinct ways to overload operators in C++. One is with member functions as part of a class definition, and the other is as separate non-member functions. In this movie, we'll be discussing operator overloading with member functions in your class definition, and we'll discuss the non-member functions in another movie. So here I have a working copy of rational.cpp from chapter 4 of the exercise files. This is a simple rational number class that performs arithmetic functions on fractions. First, I'd like to just build and run so you can see how this works. I want to show you the main here. We're creating a number of objects and we're constructing them in different ways so we can demonstrate the different types of constructors. And then we're performing some arithmetic on them using normal operators. So I can say a plus b, a minus b, a times b, a divided by b, even though a and b are these rational objects. They're not integers, they're not scalar types at all. They're these rational objects. And what happens when we perform these arithmetic computations using these arithmetic operators, what happens is defined in the class in these operator overload methods. So let's take a look at the interface. This is the class definition for the rational object. You notice that we have just two data members for a numerator and a denominator, _n and _d. Then we have constructors and a destructor and a couple of getters, numerator and denominator, so that we can get those values and inspect them. And then we have the operator overloads themselves. We have an assignment operator and the four arithmetic operators. So let's start at the top. Our constructors give us both a numerator and a denominator, and those are assigned to our _n and _d respectively. There's a technique being used here that you probably haven't seen before, and that's these equal signs in the function definition, in the function signature. And what that does is it gives these variables default values. So if I don't specify denominator, if I only specify one parameter to this function, it will assign the second one this default value, which is 1. So your default denominator is 1. If you also don't provide this one, if you provide no parameters at all, then both of these, the numerator and the denominator, will get default values. And so the numerator will get a default of 0 and the denominator will get a default of 1. So this function definition means that I can call this function with 0, 1, or 2 parameters, and it'll simply use them left to right as they're provided, or it'll give them their default values. So this is a technique that we haven't seen before, at least not in this course, and it's a useful technique. And you can use it with regular functions or with function methods. Next, we have a constructor that is the copy constructor, and the copy constructor takes one parameter and it is a reference to a rational object. So it's a reference to the same class of object as is being defined here, and that's what makes it a copy constructor. And what it does is very simple. It simply copies over the numerator and denominator from this RHS object. RHS stands for right-hand side. That's commonly used in operator overloads. Each of these in our definitions will have a right-hand side, and the left-hand side is the object itself. Then we have a destructor, and we'll look at that in a minute. And we have the getters for numerator and denominator, and those are very simple. You've seen that before. You notice that they're constant safe. All of these are constant safe with the exception of the assignment operator, which obviously cannot be constant safe because it needs to change these data members. And then we have our operator overload. So we have one for assignment, we have one for addition, subtraction, multiplication, and division. Each of these are constant safe, and each of them takes a constant rational reference. So very simple. Let's take a look at well, first of all, let's go ahead and run this. So I'll build and run, and this is what our output looks like. I'm just going to walk through it real quickly. You notice our first one is using an implicit type conversion. In other words, it's just using an equal sign. And so that ends up using this first constructor with just the one parameter. And so it assigns the numerator and it gives the denominator a default of 1. And so you'll notice that I gave it a value of 7. And so we ended up with 7/1 as our rational number. The second one constructs with 2 parameters, 5 and 3, and that gives us 5 over 3. The third one is a copy constructor, so C also gets 5 over 3. D is constructed with the default constructor, and so it has no parameters, so it gets 0 over 1. Then we have an assignment operator. We're assigning the value of C to the value of D, and so we're using our overloaded assignment operator, and so D becomes 5 over 3. Then we're constructing a reference object as a reference to D, and then we do an assignment to self, because D and E are now the same object, and I'll show you how that's caught. That's actually not a valid thing to do, and so I'll show you how that's caught in our assignment operator. And then you see that E is still 5 over 3, just like D is. And then we have our 4 arithmetic operations, plus, minus, multiplication, and division, and here's the results of those, which are the results that we would expect. Now, let's take a look at how this is all done. Here's our operator overloads for the arithmetic operations. Each of these is pretty much the same, with the exception of the formula. And so what this does is it constructs a temporary object called rational, and it returns that temporary object without ever giving it a name. And so this is how that's done. And that temporary object gets created just for this purpose and then immediately destroyed after it's used. And so when we get to the destructor, we'll go ahead and we'll put a printf in the destructor so that you can see when each of these is destroyed, and you'll get an idea of how this actually works. These temporary objects, they just get created for the purpose of returning a result, and then they're immediately destroyed after they're used. So you'll see that there's 2 parameters in this constructor. The first one is this expression, which multiplies the numerator by the right-hand side denominator, and then multiplies the denominator by the right-hand side numerator and adds them together. And that becomes the new numerator, and the denominator is simply the product of the denominator and the right-hand side denominator. And so that's just the formula for how this is done, and you can look that up anywhere. But the thing that you want to understand is that I'm constructing this object with the constructor that we built up here with a numerator and a denominator. And so that's really all there is to it. And each of these operations works exactly the same way. The operator overload is defined by giving the name of the member function as the operator keyword followed by the operator itself. And sometimes you'll see this without the space. I like to put the space in there. I think it makes it a little bit more clear, but you'll often see it like this, and that works exactly the same. And so you can see the results of those. I want to talk a little bit about the assignment operator. The assignment operator uses the this pointer, which we've talked about before. And so it basically, first it tests if this is the same as the address of the right-hand side. You notice the right-hand side is being passed as a reference, so we can get its address, and we can see if we're assigning to ourself. And if we are, we simply return ourself, because there's no actual assignment that needs to happen. And if we're not assigning ourselves, then we simply copy the numerator and the denominator from the right-hand side. And so you see down here, when we do this assignment to self, nothing happens. E remains 5 over 3. It's just ignored. And so that's how we catch that. And then we're returning as a reference, you see, because it's declared to return a reference, we're returning as a reference the this object. And so we use this asterisk to dereference the pointer so that we're actually returning a reference to the object itself and not a reference to the pointer. So that's how that works. I want to demonstrate real quick the temporary objects. And we can demonstrate that by putting a printf in the destructor. Detour stands for destructor. You'll often see it printed that way. %d over %d and a new line, and we'll give it the numerator and denominator. And so when I run this, you can see the temporary objects getting destroyed. And let's go down here and take a look at this. This starts happening when we do the arithmetic. We add a plus b, and that returns a temporary object, which is used for the purpose of this cout. And then after the cout is done, the temporary object is destroyed. So you can see detour 26 over 3. There is no object, none of these A, B, C, D, or E have that value. That value is just for the result, and then it's thrown away. And so the same for subtraction, multiplication, and division. And then after the division object, the 2105, then each of our four objects, A, B, C, and D, are destroyed, E doesn't get destroyed because E is just a reference to D. So those are all our destructions happening. Finally, the assignment operator, the interesting thing about this, because it needs to return this reference so that assignments can be chained. So if I come down here at the end of this and I say D equals C equals B equals A, and then I print all of these out again, and I'll just copy that 4 times and we'll print A, B, C, and D. And now when I print this, you'll see they all have the same value. And that's because the assignment operator is actually returning a reference to itself. And so that allows it to be used on the right-hand side of another assignment operator. And this is the reason that you do this, so that you can chain assignments, because this is something that is expected of the assignment operator in C++. So one final thing that I want to show you here, and you'll notice this is why I'm using cout. I don't normally use cout. The reason I'm using cout is because I want to show you how to overload this left shift operator so that it works with cout, because a lot of people like to use cout, and this is how you can make your class work with it. And so this is actually a non-member function overload. It's not a member function overload. And you notice I have the comment, this is useful for cout. And so it uses this O stream, which is included as part of the IO stream header. And so that's why we include the IO stream header up there. And this is an operator overload of the left shift operator that returns an O stream object. And it takes an O stream object on the left-hand side and a rational object on the right-hand side. And then it simply returns the O stream object, and it uses the left shift operator with that O stream object just as you would a cout, and you give it parameters just as you would a cout. And so it's returning the numerator and the slash character and the denominator. And that's what allows us to be able to do this, to use our object with a cout with its little overloaded left shift operator. And so that's a technique that you may find useful in the future. So this is operator overloading with member functions. Operator overloading is a fundamental part of C++. It's as easy to do as defining a class method. We'll look at non-member functions for operator overloading in the next lesson.